Okay, now we answered those earlier questions. Just to remind you, here's the question again about the golfer. Very similar to the one I gave you in the test. Just changed some numbers. And we're moving now on to the last couple of parts. So finding the distance first of all. So we've dealt with the height. We just need to carry on what we were doing earlier to find the total time that the ball was airborne for. From that, we can work out our distance, because if you remember, for distance, we simply use x vx t. Okay, that's just the distance in the horizontal direction equals the speed in horizontal direction times time. Distance is speed times time. Dead easy, because there's no acceleration. Unfortunately, from the question, we don't have the distance. If you read it carefully, it tells us the distance the ball lands from the hole, but we've no idea how far it's gone. And we don't have the time. So we can't yet find x. We've only got one of these. So we worked that out from our vector earlier. So we know that one. So to find the time, well, we're not going to be able to find it from this. So we need to continue our SUVAT. We already established that the ball went up to a height of about 18 meters. So now we're going to look at the ball coming back down again. Okay. So initially the velocity was, well, in fact, we can work out, there's two ways to work out time, but we'll go with this way because we've got more of the knowns. Okay. I'll just quickly recap. We had the initial velocity over here of 18.7 meters per second. Remember, that's up. Okay, so that's our u. V, we know at the top is going to be 0. We've worked out s, but let's just use what we know. We know gravity is minus 9.81. So now we're looking for a SUVAT equation that doesn't contain s, because we're not using s at all. We want to find t. Okay, SUVAT. T, that's what we're trying to find. A is minus 9.81. V is 0. U 18.74, and forget about s. We've just worked it out, but in case we worked it out wrong, we'll not use that one. But we know these are more likely to be true. So what SUVAT equation do we use? Again, we look back at our SUVAT sheet. We find one without an s. It's the first one, the simple one. Makes it nice and easy. V equals u plus at. Rearrange that so you get v minus u all over a is equal to t. So to find t, we put in 0 minus 18.74 divided by minus 9.81. Minuses cancel out. So 18.74 divided by 9.81. So that gives us a time there to get to that point of 1.91 seconds. But remember, we've just worked out the time to go from here up to the maximum height where v equals 0. Tried to work it out over here, we'd probably get into some trouble. So we've only worked half of it. Now, because we're assuming no air resistance and all the rest of it, we get this lovely parabolic path, not lovely drawn by me, but we would get a perfect path over here. So we know that if we just double that, it's going to be symmetrical. So the time there times 2 gives us the full time. Times 2, and then t therefore equals 3.82 seconds. Okay, so now we have the time, we can substitute that back into all our horizontal data. So we're now thinking about our whole path. We know that the whole thing took 3.82 seconds. We worked out earlier that our horizontal velocity, which is going to be the same all the way across wherever this ball goes. So if we were a bird flying over at the same time looking down, we would just see a straight line. Okay, and that velocity we worked out from using h cos theta for the initial velocity in that direction. We worked out the horizontal component to be 65.37 meters per second. Okay, so it's traveling quite quickly in the horizontal direction. Okay, we want to find that distance, that horizontal distance, x. And then once we've got it, we can work out where this hole is. We know it's over here somewhere. Sticking out the ground. Yay, hole. So x equals vxt. You know, I usually tell you to write them all down the side like this. So you've got them. X is what we're trying to find out. V is 65.37 and T is 3.82. Write them in that order and then you know it's X equals VT. X equals VT. Okay, so we do 65.37 times 3.82 and that comes out as a distance of 250 meters. Okay, so that's our range there, X. But that's not our answer to that part of the question, because if you remember, the question said, part 4, find the distance to the hole of the hole from the tee. Okay, so we've hit the ball 250 meters, but the question also told us that it landed just short of the hole by 80 meters. So all we need to do is just add that bit on, because if you like, this distance here, or rather this entire distance, is x plus 80. So we've worked out x. So just this bit here was 80. So x, 80, x plus 80. Okay. So the answer would therefore be 250 plus 80. So we get 330 meters. Okay. Finally, to work out the final velocity, it's the last part of the question, you're talking about when the ball impacts into the ground. Which direction is it going? Now we should find, because it's all level and it's all symmetrical, that it's just the same as when it took off in a slightly different direction, but we'll just prove it mathematically just to go through the principles so you know how to do it.